Welcome to Module 2. In this module, we will focus on two key areas of material handling: hoisting equipment and conveying equipment. The content of this module is essential because in most industrial and commercial environments, both hoisting and conveying systems work hand in hand to facilitate the movement of raw materials, components, and finished products. By the end of this lecture, you should be able to identify the different types of hoisting equipment and their components. Understand the working principles of pulleys, sprockets, drums, load handling attachments, arresting gears, and brakes. Explain the operation of various conveying equipment, including belt conveyors, oscillating conveyors, chain conveyors, bucket elevators, screw conveyors, and pneumatic conveyors. 1. Hoisting equipment. Hoisting equipment refers to machinery designed to lift or lower loads using mechanical means. It is used in applications ranging from construction and shipping to manufacturing and warehousing. The purpose of hoisting is to raise loads safely and efficiently, often over significant vertical distances, and sometimes to also move them horizontally. This equipment may be operated manually, electrically, pneumatically, or hydraulically. 1.1 Flexible hoisting appliances. A flexible hoisting appliance is the medium or element that connects the load to the lifting machine. Common types include wire ropes. They're made of multiple strands of wire wound around a core. They are flexible yet strong, making them suitable for cranes, hoists, and elevators. Chains, often made of alloy steel for strength and durability, used where resistance to abrasion and high temperatures is important. Synthetic slings, made from materials like nylon or polyester. These are lightweight, flexible, and ideal for delicate loads to prevent damage. Choosing the right flexible hoisting appliance depends on factors such as load weight, the nature of the load, lifting height, environmental conditions, and frequency of use. 1.2 Pulleys. Pulleys are simple machines that use a wheel and a rope or chain to change the direction of force and sometimes to gain a mechanical advantage. In hoisting systems, single pulleys simply change the direction of the lifting force. Block and tackle systems combine multiple pulleys to multiply lifting force, enabling a smaller input to lift a heavier load. In practical terms, pulleys reduce the effort needed to lift loads and are fundamental in cranes, hoists, and elevator systems. 1.3 Sprockets. Sprockets are toothed wheels that engage with chains to transmit motion and force. In hoisting systems, they are used in chain hoist and conveyor drives. Unlike pulleys, which work with flexible ropes or belts, sprockets work specifically with chains, ensuring positive engagement without slippage. This makes them ideal for applications requiring precise movement. 1.4 Drums. Drums are cylindrical components around which cables or ropes are wound to lift or lower loads. They are a core part of winches and some types of cranes and elevators. The drum's diameter, material, and surface finish all affect the rope's bending stress and lifespan. Larger drum diameters reduce rope fatigue, while grooved surfaces help guide the rope evenly. 1.5 Load handling attachments. Load handling attachments are devices designed to connect the hoisting equipment to the load. Examples include hooks, general-purpose attachments for many lifting tasks. Grabs, claw-like devices for bulk materials like scrap or gravel. Magnetic lifters, for lifting ferrous metal objects without slings or chains. Vacuum lifters, for smooth-surfaced loads like glass panels or sheets of metal. The selection of the right attachment is critical to ensuring load security, safety, and efficiency. 1.6 Arresting gears and brakes. Safety is paramount in hoisting. Arresting gears and brakes are mechanisms that prevent uncontrolled load movement in case of system failure. Arresting gears lock the hoist or elevator carriage in place if it exceeds a certain speed, preventing a free fall. Brakes control movement by applying friction to halt or slow the load. Brakes may be mechanical, hydraulic, or electromagnetic. 1.7 Hoisting and traveling gear. In many hoisting systems, the load must not only be lifted vertically but also moved horizontally. Traveling gear refers to the system that moves the hoist or crane along a track or beam. This allows precise positioning of the load, whether on a factory floor, in a warehouse, or at a construction site. 2. Conveying equipment. While hoisting deals mainly with vertical movement, conveying equipment moves materials over fixed horizontal or inclined paths. Conveyors can be manual, powered, or gravity-driven. 2.1 Belt conveyor. The belt conveyor is perhaps the most common and versatile type. It consists of a continuous belt, made of fabric, rubber, plastic, or metal, stretched over pulleys at each end. Advantages: continuous movement, gentle handling of materials, adaptability to inclines, and ability to carry a wide variety of loads. Applications: airports, baggage handling, factories, warehouses, and quarries. 2.2 Oscillating conveyors. Oscillating conveyors use a trough that oscillates back and forth to move materials by inertia. Advantages: gentle handling for fragile materials, ability to handle hot materials, and simple construction. Applications: foundries, food processing plants, and recycling facilities. 2.3 Chain conveyors. Chain conveyors use one or more endless chains to move materials along a track. Advantages: robustness, ability to handle heavy or bulky loads, and suitability for harsh environments. Applications: pallet transport, automotive assembly lines, and heavy machinery manufacturing. 2.4 Bucket elevators. Bucket elevators are vertical conveyors that use a series of buckets attached to a belt or chain to lift materials. Advantages: efficient vertical lifting of bulk materials, enclosed design to reduce spillage. Applications: grain elevators, cement plants, and chemical factories. 2.5 Screw conveyors. Screw conveyors use a rotating helical screw blade, flight, inside a tube or trough to move materials. Advantages: can handle a wide variety of materials, including semi-liquids, enclosed to prevent contamination. Applications: agriculture, food processing, waste handling, and chemical industries. 2.6 Pneumatic conveyors. Pneumatic conveyors use air pressure or vacuum to move materials through a pipeline. Advantages: can move materials over complex paths, enclosed system prevents contamination and dust. Applications: powdered or granular materials in industries like pharmaceuticals, food processing, and cement. 3. Integration of hoisting and conveying systems. In most operations, hoisting and conveying equipment do not work in isolation. A manufacturing plant might use overhead cranes to lift heavy components onto a conveyor, which then moves them to the next processing stage. Similarly, ports combine container cranes with conveyor belts to move bulk cargo efficiently. Integrating these systems improves material flow, reduces manual handling, and enhances productivity. 4. Safety considerations. Whether hoisting or conveying, safety is critical. Common safety practices include regular maintenance and inspection of equipment, proper training for operators, adherence to load limits, use of protective devices like guard and emergency stop controls, compliance with relevant safety regulations and standards. In this module, we explore the details of hoisting and conveying equipment. We examine the components of hoisting systems, from flexible hoisting appliances to arresting gears, and looked at the main types of conveyors and their applications. These systems form the backbone of material movement in countless industries, and understanding them is essential for designing efficient, safe, and cost-effective operations.